Asynchronous programming is everywhere these days. It doesn't matter if you're on the client or the server. On the client, you want asynchronous operations to take place because you want to keep the UI thread free. You don't want it to block on I/O operations because then the UI freezes and it doesn't respond to the user's mouse clicks. This is why the A in AJAX stands for asynchronous, and it's partially why AJAX makes browser applications more responsive. It just keeps that UI thread free. On the server, we also want async operations because that keeps the request processing threads free from blocking on I/O operations. It keeps them busy in executing and servicing network requests. There's such a demand for async programming these days that Microsoft introduced new keywords into the C# language to make async programming simple. The keywords are async and await. A method marked with the async operator is what we call an asynchronous method. And inside of any asynchronous method, the await operator can suspend execution of a method until some task is complete. While the method is suspended, the caller is free to continue processing, and the calling thread can work without blocking and waiting for that method to finish. As a result, you can write code with a logical flow, but behind the scenes there's actually a thread jumping in and out of the method and keeping that thread busy. Asynchronous methods always return a task or task of T. Ideally, you can also return void from an asynchronous method, but it's not usually recommended because the task is there to represent the work that is outstanding that needs to be completed. And if you don't return a task, some frameworks can run into trouble because they don't know when your work is complete. So you typically want to return a task or task of T, and the method name itself should end with the word async. That's a clue to the caller that this is an asynchronous method. You'll find these async methods now all throughout the .NET Framework in 4.5. And inside an async method, you should see one or more of these await operators. Those are the points where the thread of execution can jump out of the method and continue working somewhere else. Now, the async operator doesn't mean that this method will execute on a different thread. It simply means that the current thread calling into the method doesn't have to block inside of that method. Async and await essentially provide cooperative multitasking for a thread so it can stay hot. Let's take a look in our console application. Inside of the console mode application, I'm going to change slow operation into an async method. And that's as easy as adding the async keyword, but I need to make a few other changes too. First of all, I should really return a task of int instead of just an int now. In fact, I have to return task or task of T or void. And I'm going to change the method name from slow operation to slow operation async to follow the conventions set forth by the .NET Framework. Now, the other different thing I'm going to do inside of here is I'm going to use the await keyword. And instead of doing a thread.sleep, which blocks the thread, I'm going to do an await task.delay for 2000 milliseconds. That still introduces a 2-second delay, but instead of blocking the thread, it creates a task that represents work that has to delay for 2 seconds, and we're going to await that. So imagine if this was a call to some other web service or some I/O operation, some other method that ends with async. I could await that async method, and that means the calling thread that calls into slow operation doesn't have to block at this point anymore like it did with a thread.sleep. Instead, it can await some task that represents a delay of 2 seconds. And since it's awaiting, the calling thread can jump out of the method at this point, continue processing somewhere else, and then that original thread or maybe some other thread, when this delay task is finished, can jump back in here at this point and finish off the method and complete the work. Now that slow operation async is an async method, and the C# compiler is essentially going to generate a bunch of code behind the scenes that takes care of creating tasks and running a task and all that, I no longer need to do a start new on a task. Instead, I can just invoke slow operation. That will give me a task back, invoke slow operation async, and I can still get the result here. And I can still do all the other things that I might want to do with a task, like explicitly wait for it to finish at a certain point. That's a blocking call. Or using is canceled, is complete, continue with. But we'll continue going with this pattern where we just kick off the async operation, do some other work like printing out some numbers, and then we're ready for the result. At this point, we'll block if need be so we can print out the result. And now if I run the application, it's going to be a little bit different than what we saw before. You can see that the slow operation started on thread 1, which is the same thread that started into the main method. So we didn't jump to a different thread just by calling slow operation async. It was the same thread that was in the main method, but when we got to that delay, it got to come back and print out its numbers, and it just so happens in this case, in this console mode application, a different thread with an ID of 4, finished that async method for us, and printed out the message slow operation completed on thread 4. And this is why you can think of async await as a bit like cooperative multitasking. And in some environments, the thread that finishes that async method is going to be the same thread that started it. Most notably, if you're in an environment like WPF or Silverlight, where you have to perform certain tasks on a specific thread, like the UI thread, then you can use async and await with the UI thread and always have the UI thread start the task and end the task. But it can do other work in between while the long-running I/O operations are executing, like responding to events and keeping the UI refreshed and responsive. In ASP.NET, just like in this console mode application, you can see your code execute on different threads as it winds through these asynchronous methods, but that's not guaranteed. You can safely assume, though, if a request does jump threads, that the threads involved will always have the proper HTTP context for the request they are processing, and also the proper user identity and culture settings. Let's just go ahead and see how async and await work in MVC4.